Hey everyone, so this next lesson is about angles. So we're going to learn all the basics of angles, like how to classify them, how to name them, the parts of an angle, what else, angle addition, and some other definitions. So here we go, let's get started. Okay, so first we will define an angle. So an angle is a figure formed by two rays with the same endpoint. So right here, that's an example of an angle. See how this is a ray? And this is a ray. So they have the same endpoint, sort of like opposite rays. Opposite rays technically make an angle, and you'll see why in a second. So if I ask for the sides of an angle, that's one part of the angle. It's the rays that form the angle. The vertex is where those two sides meet. It's the common endpoint that they have. And then angles are named using 3 points. So we'll get to that in a second. Let's focus on the first two, the sides of an angle and the vertex. So if you look at this example here, this would be one side, ray AB. This would be the other side, ray AC. See how they have this common endpoint A? That's the vertex of the angle. Super important. So over here for the vertex, we can say the vertex is point A. The sides, like I said, are rays. So it'd be ray AB and ray AC. Okay, now let's talk about naming angles. So in this little blurb here, angles are named using 3 points. The order doesn't matter, however, as long as the vertex is listed in the middle. So that's very important. This A here has to always be in the middle. So when I'm naming this, you kind of just like go around the angle. Like you start on one side, so B, then to A, then to C. That would be one, angle BAC. Or you can say angle CAB. As long as you're doing A in the middle, the order doesn't matter. If this had other points on it, like if there was a D here, then it could be called BAD, DAB, CAB. The list goes on. So the more points you have on the angle, the more options there are to name the angle. So the important part here is that you remember that you can name it with 3 letters as long as the vertex is in the middle. So for possible names, we're going to say angle BAC, angle CAB. Now this particular angle, because it's the only angle in the picture, I can also use the vertex. But again, that's only if it's the only angle in the picture. So I could also call this angle A. So we might want to add in a little note here that says, can use the vertex if it is the only angle in the picture. And I'll show you what I mean. So this one I could call angle A. If I added another ray here and called this D, I can no longer call any of these angles angle A, because if I said, hey, find the measure of angle A, well, which one are you talking about? There's this one that has A as the vertex, there's this one that has A as the vertex, and then there's the whole thing that has A as the vertex. So once you add in more rays to a vertex, you can no longer name it by that one letter because we wouldn't know what you were talking about. So that's how we name an angle. The 3-letter thing, that can be used all the time. So that's the good one to remember. Okay, another definition is an angle bisector. So an angle bisector is a ray that cuts an angle in half pretty much. So that word bisect we'll be referring back to at other points throughout the year. Bisect means to cut in half. So anytime something is bisected, whether it be a segment, an angle, whatever, it's cut in half. So if you look at this picture here, in this, it says that OY bisects XOZ. So this ray cuts XOZ in half. See these markings right here? What those markings mean, it's kind of hard to see, but they did an arc with 1 tick mark and an arc and 1 tick mark. That's how you can show that angles are congruent. You can also do the same number of tick marks. Like I could put, not the same number of tick marks, the same number of arcs. Like I could put 2 arcs on this one and 2 arcs on this one, and that would mean that those angles are congruent. It's kind of like the tick marks that we learned on the segments. You'll see we'll do a lot of marking angles at some point, so you'll get used to that. And I wrote it here in this little blurb. The arcs show equal angle measures. Okay, the next thing about the basics of angles is classifying them. You probably learned this, I don't even know, elementary school, I think. We're not really going to do practice with this, but these are words that you should be familiar with. An acute angle is one that's in between 0 and 90, that cute little angle there. A right angle is exactly 90. An obtuse angle is bigger than 90, but less than 180. And then a straight angle is exactly 180. So those are ways that we can classify angles by their measure. The next thing we're going to talk about is the angle addition postulate. So you may remember the segment addition postulate that we learned in the last lesson, where the two small segments add together to equal the big segment. This is the same idea, but it's just with angles. B is in the interior of ADC. So this is ADC. B is in the interior. They don't mean B is just floating. They mean B is on a ray in the interior. Interior just means inside. So what this says is that ADB, this angle, plus BDC, this angle, would equal the whole thing. So like if I said this one's 20 and this one's 30, we would say the whole thing is 50. Okay, that is not an accurate measure. I just made those up off the top of my head. Whoops. Okay, so to fill this in here, we're going to say that the measure, that's what this little m means, the measure of angle ADB, so when you see that little m, that means measure, plus the measure of angle BDC equals the measure of ADC, the whole thing. So small plus small equals big. So that's angle addition postulate. So let's do a few examples. This one says F is in the interior of ABE. So let's make a picture. I need an angle ABE. Okay, there's my angle. F is in the interior. So F, we can't just have floating out in the middle of nowhere. We need to stick it on a ray. So that's what that picture would look like. F is in the interior of ABC. Let's label it. It says the measure of angle ABF, this one here is 62. And the measure of angle FBE, is 60. I did not draw this to scale. So see, I didn't know what the measures were ahead of time. Well, I guess I could have looked at it. I just sketched it. So when you're drawing a picture, it doesn't have to be like exactly to scale. Just sketch it so you have a good idea of what's happening. So it wants us to find the measure of angle ABE. So that's the whole thing. ABE. So you would just add those together. So 62 plus 60 would be 122. So obviously I did not draw my picture to scale, and that's okay because this is an acute angle, not an obtuse one, but it's fine. So that's a very, very basic angle addition problem. Next one. So it says EBC is 82. EBC. So you always want to, if there's not a picture, draw one. If there is a picture, label it. That is so important in geometry. Label the picture with the given information. You're going to hear me say that over and over and over again. Okay, next, FBD. FBD, this one here, is 88. And then FBE, let me use a different color. FBE, this one here, is 51. So this is asking us to find DBC. This is the one we're trying to find. So if you want to take a second, think about this. If you even want to pause the video, try it on your own. I'm going to go over it now. Basically, see how this blue one is 88 and this green one is part of it. So this green one plus this empty one would add together to give us 88. So if we just do 88 minus 51, that will give us EBD. So 88 minus 51, that would be 37. So that angle is 37. Now we just have to do 82 minus 37. That will give us the last piece. So it's going to be 45. So the measure of angle DBC is 45 degrees. Okay. The next one is actually dealing with the same picture. So I'm going to erase this. And we're going to label it for, so this is this picture. So we were given that BD, ray BD bisects angle EBC. So that means this is congruent to this because this bisects this angle. So it cuts it in half. So those pieces are equal. Then they gave us that the measure of EBD is 4x plus 16. The measure of DBC is 6x plus 4. Notice I'm labeling the picture. Find the measure of EBD. So we're first going to have to find the measure of the value of x, rather. So the only thing I know about this picture, sure, these two small ones add together to give us the big one, but we don't know the big one. We do know that this bisects the angle, right? That makes this one equal to that one. So you can actually set things equal to each other in geometry. So you can do 4x plus 16 equals 6x plus 4. And so in geometry, when you have to solve for x, your equation just needs to represent whatever is true about the picture. So you have to first know what's true about the picture and then set it up. So then we'll just solve now, subtract 4x. So 2x equals 12, x is 6. Now that we know x is 6, we still have to find the measure of angle EBD. So that was 4x plus 16. So 4 times 6 plus 16. 4 times 6 is 24. Plus 16 would be 40. So the measure of angle EBD is 40 degrees. Okay, so there's one involving a bisector. And then our last example is just a kind of a basic angle addition one again, just with algebra. So ZHG, that's this one, is 11x minus 1. IHZ, this tiny little thing, is 24. And then IHG, the whole thing, is 12x plus 13. So we're just going to do basic angle addition here. The two little ones, 11x minus 1, plus the other little one, 24, is equal to the big one. And then we're just going to solve for x. So combine like terms. So it's going to be 11x plus 23 equals 12x plus 13. Subtract 11x. So this is going to be 23 equals x plus 13. Subtract 13. So we're going to have x is 10. This also asks us to find the measure of IHG. So IHG, is the whole thing. So we can do 12 times 10 plus 13. 12 times 10 is 120 plus 13 is 133. And that's how you plug in to find angle measures or even like segments, how we did in segment addition. So that's it for the basics of angles. You're going to do some practice on this today. Some of it is very basic and some of it is going to make you think a little bit more. So you're going to apply these rules that we learned to complete the practice. So please let me know if you have any questions. And that's it. Have a great day.